Hello, welcome to the next video. Here we focus on the use of what we call sigma notation to communicate a need to add a series of numbers. It sounds a little bit strange to some people, but it really is quite a straightforward technique. We can use the technique of sigma notation for arithmetic or geometric series, but we can also use the technique for other kinds of series as well. Sigma notation is simply a quick way to write down a large number of terms in a series. Let's consider the series of numbers 2 plus 6 plus 10 plus 14. It's an arithmetic series, its first term is 2 and its common difference is 4. So now we can rewrite our terms using arithmetic series notation. The first term is 2 plus 4, which was the common difference, times the term number 1 minus 1. So we simplify that. We have 2 plus 4 times 0, which is 2, which we had originally. The second term is 2, the first term, plus 4, the common difference, times term number 2 minus 1, and that reproduces our 6, and so on and so forth. We have a constant pattern, therefore, from one term to the next, and the only symbol changing is the term number. We therefore are adding up a series of numbers which are 2 plus 4, the common difference, times n minus 1, and we use the values of n from 1 to 4 to represent the term number. We now replace the term add up with the sigma symbol, which just means add up. We then extend our writing by indicating which values of n we can use, here from 1 to 4. So we put the 1 at the bottom of the sigma sign and the 4 at the top of the sigma sign. When we replace the n term in the expression with the values 1, then 2, then 3, then 4, we reproduce our original series. Clearly the result of adding the 4 terms together is 32, but we are here only trying to rewrite the series in our new notation. The sign is really interesting. We just call it sigma, and it means add up a series of defined or given numbers. It's derived from the idea that it was the 18th letter in the Greek alphabet. It's the capital letter version, the uppercase form. In Greek numerals, it represents the number 200, so it does a lot of things. It is pronounced when you're actually reading text as a sh, with the tongue touching the teeth. And it was recently replaced in the African reference alphabet with the equivalent lowercase letter, which is the integral sign. So interesting, because now they both mean sum. Recapping, we say that sigma n means add up the numbers defined by the expression n, while sigma n from n equals 1 to n equals 4 means add up the numbers starting at 1 and stopping at 4. So 1 plus 2 plus 3 plus 4, the answer is 10. Similarly, we may have sigma from k equals 9 to k equals 10 of 1 over k. So we're just starting at k equals 9, we have 1 over 9, add 1 to that, we have our last term 10, which is 1 over 10. 1 over 9 plus 1 over 10 is equal to 19 over 90. Equally common questions you will encounter involve a general term for an arithmetic series or for a geometric series. In this case, I've got sigma from n equals 3 to n equals 5 of the expression 2n plus 1. So we've got to add up the terms where n equals 3, then 4, then 5. Take 3, substitute it, 2 times 3, 6 plus 1, n equals 4. We have 2 times 4 is 8 plus 1, and then we have 2 times 5 is 10 plus 1. So we have the term 7 plus 9 plus 11, which of course is 27. just substitute in. We could have an arithmetic series with a negative common difference. So sum sigma from k equals 6 to 9 of 20 minus 2k. You recognise that equation as a linear equation, and the common difference is minus 2. So we start with k equals 6, 20 minus 2 times 6 is 20 minus 12, which is 8, and so on and so forth. We have the sequence 8 plus 6 plus 4 plus 2. Add them together, we have 20. The final type of question asks you to create the sigma term rather than giving it to you. These questions will either be very obvious as to how to write a general term. For example, we might be given 2 over 3 squared plus 2 over 4 squared plus 2 over 5 squared and asked to write that in sigma notation. Well, there is a common 2 in the numerator of each term, while the number in the denominator, which is squared, begins as 3 and finishes at 5. So we can write sigma from n equals 3 to 5 of 2, which was the common number, over n squared. Other questions asking you to write a series in sigma notation are simply asking you to calculate a general term. For example, we may be given 5 plus 11 plus 17 and so forth. So we've got 6 terms here. And what do we know? We know that it's an arithmetic series. The first term is 5, the common difference is 6, and we have 6 terms. So the nth term can be written as 5, the first term, plus n minus 1 times the difference of 6. Tidy that up, we have 6n minus 1. So now we can rewrite that in sigma notation because we're adding up those 6 terms. So it is sigma from n equals 1 to 6 of 6n minus 1. It's a little bit like the first one, but we've got one more extra step. It's exactly the same approach for writing a geometric series in sigma notation. We might be given 3 plus 6 plus 12, etc. And what do we know? Well, it's a geometric series. The first term is 3, the common ratio is 2, and we have 7 terms. So we write our general term for a geometric series as Tn equals the first term 3 times the common ratio 2 raised to the power n minus 1. So if we put that into sigma notation to reflect that we have to add them up, we say sigma from k equals 1 to 7 of 3, which was the first term, times the common ratio raised to the k minus 1. In summary, sigma notation is a strategy to write down a simple expression to summarise a question requiring the addition of several terms, all of which have a common format for their calculation. We use the symbol sigma from the Greek alphabet to mean add up all the bits defined after the symbol. The limits to the number of terms we have to add up are shown by the numbers at the bottom and at the top of the sigma sign, and we use all integers between those limits. So you now have the steps to talk sigma terms. Hope I've helped you to clarify the approach and that you now think it's pretty straightforward. As this is a standalone video within the sequence and series topic, you could now go and do some of the applied questions or some of those that mix arithmetic and geometric series together. Hit the like button and subscribe if you haven't already. Go and do some questions on sigma notation in Test Yourself 1 on my website, drjaysmaths.com. Just click the back arrow, add a comment or send me an email if you have any questions. Good luck, enjoy Sigma, bye.